In this video, you're going to be learning about inverse variation and then also how to use inverse and joint variations. In the past, we have talked about direct variation. It is very much like a proportion. As one increases, the other increases, and the formula is y equals kx for a direct variation, where k is a constant. So for example, y equals 5x, y equals negative 2x, those are all direct variations. And to solve for k, you would divide both sides by x. So another general form of using this would be y divided by x would equal k. That is actually how you could find what the constant would be. So where you would use this in real life is, for example, the more hours you work, the more you would get paid. The greater the speed of a car, the greater the distance traveled in the same amount of time. Whereas in the reciprocal of it, inverse variation is y equals k divided by x. Again, where k is any constant. So for example, y equals 5 divided by x, y equals 2 over x. Those are all inverse variations. And inverse means that if one increases, the other one's actually decreasing. So for example, the more people you have, the less time it would take to finish a job. The faster you drive, the less time it takes for you to arrive at your destination. And then to solve for k in this case is you would multiply both sides by x. And so whereas here, y divided by x will get you k, in this, k would equal y multiplied by x. So for example, let's say that x and y vary inversely. And x is 3 when y is negative 5. Write a function that will model the variation. First thing we're going to do is find k. We know that it's an inverse, so we are going to say y equals k divided by x because that's a formula for the inverse variation. Now I'm going to plug 3 in for x, and I'm going to plug negative 5 in for y, and I'm going to solve for k. So to solve for k, I'm going to multiply both sides by 3, and k equals negative 15. Now that we found k, it is negative 15. Now we can find the inverse, we can find the actual function that would model it. So again, the function is y equals k divided by x, and now we know k. It is negative 15, and that would be our general function. You may ask, why didn't I use 3 and negative 5? You do. You use it to find k, but then you write the variables anytime you are wanting to actually write a model function. And so you would use the numbers to find k and then plug the value for k in. Now you can also do it by tables. You can identify whether something is a direct or an inverse variation based off of its table. So again, direct variation, so if I say dv is going to be y equals k times x, or it would be y divided by x would equal k. And then an inverse variation is going to be y equals k divided by x, or y times x equals k. So k has to be the same constant. So either we're going to divide each sets of terms by the same, or we're going to be multiplying by the same. So if you look at 6 and 4, and then look at 12 and 2, 8 and 3, if I multiplied 6 times negative 4, I would get a positive 24. If I multiplied 12 times 2, I would also get a 24. Negative 8 times negative 3, positive 24. And again, that also give you 24. Since I had to multiply x times y to get 24, which happens to be my k, that means I used an inverse variation. So this table is going to be an inverse variation because I multiplied the two variables in order to get my constant. Now in this next table, if we were to multiply each term, 3 times 6 would give me 18, 4 times 8 would give me 32. Obviously these are not the same constant, so you cannot say that that's an inverse. So let's try dividing. If we, in this case, this would be y divided by x. So if we did y divided by x, 6 divided by 3 would give you 2. 8 divided by 4 also gives you 2. 10 divided by 5 gives you 2. And 12 divided by 6 gives you 2. So if you were to divide y divided by x, you would get the same thing, the same constant each time. So therefore, this was a direct variation. Again, because You divided y by x in order to get there. So let's go to the next one. So first, let's multiply. 5 times 25 is 125, but 60 times 12 gives you 720, so that would not work. That means it cannot be an inverse. So let's try a direct. Let's divide again to see if that will work. Y divided by x, so 25 divided by 5 would give you 5. 65 by 12 also gives you 5. 35 divided by 7 gives you 5, and 40 divided by 8 gives you 5. So therefore, it was a direct variation. Again, because you divided by them. This next one, let's try with multiplication. 9 times 4 is 36. 18 times 2 is also 36. 6 times 6 is 36. And 12 times 3 is 36. Therefore, since we multiplied x times y, we use this formula right here, the x times y, which is the inverse formula. So that table represented an inverse variation. Now, you can also find a missing value based off of these. So, for example, suppose that y varies inversely with x, and y is 50 when x is 4. Find x when y is 10. So, let's first use what we know. When y is 50, x is 4. So to solve for k, I would multiply both sides by 4, and I would get 200. Now that we know k, we can say y equals k divided by x, and we know that k is 200. Now we're going to plug in what we know next. Find x when y is 10. So now we are going to get 10 for y, and I'm going to replace it. So to solve for x, I'm going to multiply both sides by x and get, when I divide by 10, I will get 20. So my answer will be 20. Now in this case down here, suppose that y varies directly with x, and the same thing applies. So the direct variation is y equals kx. So I know that y is 50, and I know that x is 4. So to solve for k, I'm going to divide by 4 and reduce. I'll get 25 over 2 equals k. So y equals 25 over 2 x. And now I know that y is 10. So now I'm going to plug 10 in for y. And now I can cross multiply. 2 times 10 is 20. And then that equals 25x. And so to solve for x, I would divide both sides by 25. And so x would equal 20 over 25, which means they would equal 4/5 would be your x value. Again, to go from here to here, I just reduced. 50 divided by 4 is 25 over 2. Now, the next part is joint variation. Joint variation, again, using k as a constant, means that you actually can have more than 2 variables that we've dealt with. So, for example, z varies jointly with x and y. That means that you would multiply the x and y times k. Again, jointly means that you're just multiplying by the constant. So in this next part, z varies directly with the square root of x. Directly and jointly basically mean the same thing. You are multiplying by that. And it says the square of x. So that is why you would use kx squared. You're multiplying by the constant. In this next one, 2 different things happen. Z varies directly with x, which is why it's kx, but then inversely with y, which is why the y is in the denominator, because inversely means you are dividing, you are placing in the denominator. This fourth one z varies directly with x, so that's why you have kx at the top, and then inversely with 2 different variables. So it's inversely with w and with y, so that is y. W and y are both in the denominators. And the last one, z varies jointly with x and y. Jointly means there's more than one being multiplied. So that's why I have x and y with a k. And then inversely with just w. So based off of how it reads, that is actually how you can write the equation. So let's actually do a real life example. Sanford Stadium has a seating capacity of 92,000 spectators. It has 25 exits to be vacated in 20 minutes. The time taken to exit the stadium, so the time varies directly, so K, directly with the number of spectators, and inversely, which is division, with the number of exits. So number one, we just wrote a model for this joint variation. Again, the time taken to exit varies directly with the spectators. That's why it's spectators times K. And then inversely with the number of exits. And so that is why that is in the denominator. So you're going to write the equation just as you read it. Now, we do know the first thing we need to do is find K. Well, we know that when there's 92,000 spectators, so if I'm going to take this, there's K, the spectators is 92,000. And the stadium has 25 exits, and it needs to be vacated in 20 minutes, that's the time. So if I was to cross multiply, 25 times 20 will give you 500. And that equals K times 92,000. So the first thing we're going to do is find K by dividing by 92,000. So the first thing we're going to do is we're going to find K by dividing by 92,000. And we will get 0.0054 whenever we divide by 92,000. Now that we know K, we can now write our function again. So time equals 0.0054 times the spectators divided by the number of exits. And now we're going to do the next part. Determine the time it takes, so we're looking for time, for 51,000 spectators. So we don't know the time, but we do know this 0.0054. There are 51,000 spectators, and there are 15 exits that they are needing, that is functional for them to use. So you will get 18.36 minutes is about how long it would take to vacate the stadium with 51,000 people and 15 exits available. So let's recap. First, I want you to pause the video. I want you to attempt these two problems, and then when you're ready to see the answers, go ahead and hit resume. For the first one, it says inversely with x. So we know it's going to be y equals k over x. And I'm going to use 7 and 21. So I know that y is 21, and I know that x is 7. So to solve for k, I'm going to multiply both sides by 7. So k is going to give me 147. Now that I know k, then my model is going to be y equals k divided by x. Second, the force of the wind blowing on a surface varies jointly. Okay, so we know the force varies jointly, so k times, so it varies jointly as the area of the surface. So we can just say surface area. And the square of the velocity. So velocity squared. So that is going to be my model function. So if a wind blowing at 50 miles per hour exerts a force of 75 pounds on a surface of 500 square feet, so I'm going to use what I know from that to find K. So a wind blowing 50 miles per hour is the velocity. I also know the force. So this is going to be the velocity. So it'd be 50 squared. And the force is 75 pounds. And the surface area is 500. So to solve for this, I'm going to multiply 500 times 50 squared then I will get 125,0,0,0. And now to solve for k, I will divide. 75 divided by that would be 0.00006. 5. No, it has too many zeros. There should be a 0 right there. 1, 2, 3, 4, 5. Yes, right there. Now that I know that's K, so therefore I can say the force equals 0.00006 times the surface area times the velocity squared. And now that I know K, I can now do the rest of it. It says how much force will a wind of 75 miles per hour place on a surface of 10. So what I'm going to do, the surface area is 10, the velocity is 75, and that is squared, and we are looking for the force. So if you type that whole thing into the calculator, you will get the force would be 33.75.